Hello everyone. The conversation today is about sugar. More specifically, how the body manages blood sugar. It's important to understand that normally blood glucose levels or sugar in the blood is maintained within a narrow range. So there are many mechanisms that the body uses to maintain blood glucose levels relatively constant throughout the day. And I say this because we eat a lot of different foods and most people eat a lot of carbohydrates. So dietary carbohydrates are converted into glucose and really spike blood glucose levels. So how does the body manage blood glucose in such a way that keeps it within a relatively narrow, healthy range? So first, we need to know how much blood humans have on average. So it actually varies depending on body size. But just to have an idea, an adult weighing between 150 and 180 pounds or 68 to 82 kilograms has approximately 4.5 to 5.7 liters of blood. This is if we were to remove all blood in our circulation. So the other important thing to know is what is considered normal blood glucose levels. And this is measured under fasting conditions to avoid any interference of the food that we eat on blood glucose levels. So under fasting conditions, the normal blood glucose levels vary between 80 and 100 milligrams per deciliter, or 4.5 to 6 millimoles per liter. And this is the range that is considered normal in non-diabetic, healthy people. Now, with that said, if we consider that 5 liters of blood is the average, then the amount of glucose under fasting conditions should vary between 4 and 5 grams. This is the equivalent of 1 teaspoon of sugar. 1 teaspoon is approximately 4.2 grams of sugar, which is basically the total amount we have in our blood under fasting conditions, and it is considered normal blood glucose levels or sugar levels. Now, what's the difference between a normal person and a diabetic patient with respect to sugar blood levels? So, under fasting conditions, blood glucose levels above 120 milligrams per deciliter or 7 millimoles per liter is classified as diabetes. This is just a bit more than 1.5 teaspoons of sugar in the blood. In other words, if you have 1 teaspoon of sugar in the blood, you're normal. But if you have 1.5 teaspoons of sugar in your blood, you're now deemed diabetic. So in this context, the question that arises is, how does the body manage blood glucose if we can easily increase blood glucose levels by eating foods that are rich in carbohydrates? So to understand this, we also need to look at how much sugar people usually eat on average. So a typical Western diet contains 50 to 65% carbohydrates. Now, if we assume 60% as the average of carbs in the diet, then for someone ingesting 2,000 kilocalories per day, the total amount of carbs would represent 1,200 kilocalories or 300 grams of sugar. This equates to 65 teaspoons of sugar. So this means that your body must find ways to manage this because blood glucose levels cannot stay so high. Otherwise, diabetes ensues. So in fact, in most people, blood glucose levels are very well regulated and maintained within a relatively narrow, healthy range, as I mentioned before. And this is despite large daily variations in food intake. So then, where does all the sugar go? So let's consider the intake of carbs or dietary carbs such as potatoes, bread, banana, or cookies, as depicted in this diagram. So it turns out that all the carbs or sugars must be converted into glucose to be used by the body. So then when that happens, it gets into the bloodstream. So then a portion of the glucose, approximately 100 grams, is stored in the liver as glycogen. So interestingly, insulin is not needed for the liver to take up glucose, but it's necessary for the liver to store glucose as glycogen. So it's an insulin-stimulated process in the liver. So another organ that is crucial to clear glucose from the circulation is the skeletal muscle. And this is because skeletal muscles make up approximately 40% of body weight in men and approximately 30% of body weight in women. This tissue serves as a large compartment that stores approximately 400 grams of glucose as glycogen. Insulin, again, is necessary to stimulate both glucose uptake and glycogen synthesis in skeletal muscles. Together, liver and skeletal muscles have the capacity to clear 500 grams of glucose from the circulation if these organs are severely depleted of their glycogen content. However, complete glycogen depletion rarely occurs because between meals, there is always glycogen left over in muscles and the liver. So even though 500 grams is the maximum capacity to store glycogen in these organs, after a meal, only what has been used by these organs is replaced with new incoming dietary glucose. So we cannot assume that 500 grams of glucose will always be disposed of in liver and skeletal muscles. Another organ, which is the brain, also plays an important role in clearing glucose from the circulation. And this is because the brain consumes approximately 120 grams of glucose to fuel its activity. This occurs mostly because the typical Western diet is rich in carbohydrates. So the brain uses glucose as its main source of fuel. It does not mean that the brain only uses glucose to fuel itself. In fact, under conditions of limited dietary carbohydrate, the brain can use ketones, which serves as an alternative substrate that derives from fat metabolism that occurs in the liver. So many other organs, such as kidney, heart, red blood cells, and even the gut also consume some of the glucose derived from dietary carbohydrate to fuel their metabolic needs. However, the intake of carbohydrates is often so elevated that after all these glucose-consuming processes are accounted for, a surplus of glucose still remains. So under such conditions, the body stores glucose in the adipose tissue, and this is in the form of fat. So this is also favored by the presence of elevated levels of insulin that stimulate fat cells to make fat. So what is important here is that because the adipose tissue has almost unlimited capacities to store fat, it serves as a sink for the surplus of dietary sugar. So the more surplus you have, in theory, the more you're going to store the surplus into the adipose tissue. And these are, again, all these mechanisms take place simultaneously, and depending on how much abundance you're going to have of carbohydrates in your diet, you're going to have more of a surplus or less of a surplus, and that will also affect directly how much you gain in fat mass or you just maintain your body weight. So now you know how your body works to maintain that 1 teaspoon of sugar in your blood most of the time. So that's it for now, and I'll see you in the next.